So let's look at our rational functions. So if x is in the denominator, and just has an exponent of 1, then our graph is going to look something like this. So we're going to be in the first quadrant and third quadrant for a graph. And then we want to pay attention to these two asymptotes. We have this vertical asymptote and horizontal asymptote going through the origin. So when we get to shifting, we're shifting values up and down, those asymptotes are going to shift up and down. In terms of stretches and compressions, they won't change, but when we get to shifting, we'll talk about how those move, and that can help with making a sketch. Some other important points, once 1 over x, the points I track. So there's 1, 1, and negative 1, 1. I also think of at a half, you're at 2, and at 2, you're at a half. And same thing on the negative side, so I kind of keep those in mind as well for a rational function. If x is squared, I'm sorry, the graph is a bit different here, but we do have our y-axis here and x-axis here. So this is when x is in the denominator and it has an exponent of 2. We have the same asymptotes. We have this vertical asymptote and horizontal asymptote, so we'll pay attention to those with the shifting. And then, in terms of important coordinates, this is a little more tricky. When we're at x equals 1, we should be at 1 as well. This is a little bit off. So that should be at 1, 1, 1, 1. If we're at 2, we would be at a fourth. So that starts kind of escalating more quickly. If we were at a half, we would be up at 4. Same thing over here. So I'll kind of help you with tracking those as well. But just kind of, again, these are to get a sketch going. So with these kind of questions with exponents, these values can just grow so quickly. So it can be hard to get them all into the same graph. All right. So this first one, I can see x is in the denominator and it's squared. So my basic function is that 1 over x squared. And so I'm imagining this kind of graph, where I'm up in the first quadrant and second quadrant. Now the pieces I have, so inside the function is in the parentheses under that square. So with that, I can see what's going to happen horizontally. I have this 2 up here, and it's like a 2 multiplying. In fact, you could even rewrite this as 2 times 1 over x minus 1 squared plus 2. That might be easier to see the transformations, because then we can see the 2's multiplying on the outside of the function, so that's going to be a vertical stretch by 2. And inside the function, that's just a shift, and same thing out here. So with the x minus 1, that's telling me we're shifting to the right 1, and the plus 2 on the outside would mean we're going up 2. So with that, the vertical stretch. So if I think about my original function here, so I have my 1, 1, 1, 1. If I'm at a half, I'm up at 4 already. And if I'm at 2, I'm at a fourth. So that can give me some starting points to kind of visualize there. I want to stretch these by 2 vertically. So whereas at negative 1, positive 1, I would actually be at negative 1, positive 2. Whereas at negative a half, positive 4, I would be at negative a half and 8. So just bump up too far there, 8. And same thing on the other side, since it's all symmetry. And whereas at fourth, if I doubled that, it would now be a half. So with that, I can get a sketch going. So there's my vertical stretch. Then it's a matter of shifting, which with what can help in doing this is just thinking about shifting the asymptotes. So you have this vertical asymptote at 0, and with that we're moving to the right 1. So what that's going to do is create this asymptote at x equals 1. So it moves that vertical asymptote to the right. And then same thing, like the x-axis is an asymptote as well, and we're moving that up too. So what we can visualize, I know this is getting really messy, but with these asymptotes, that's the equivalent of where we had our axes to begin with. So with that, I'm just going to shift the graph so that it fits that area. So, oh gosh, this is, yeah. We're at the origin, and my new point was -1, 2. It's like my new origin is right here where those green lines intersect, and I would go to the left 1, up 2, and get that coordinate there. And to the left 2 and up 1/2, and to the left 1/2 and up 8, which would bring me right up there. So with that, it's just a matter of moving them. So we'd have something like this. And same thing on the other side. Just following those key points and making sure you don't cross those asymptotes. Alright, another one here. Now, I have x in the denominator and it doesn't have an exponent, so with that, my basic function is just going to be the 1 over x. So with that, I'm in the first quadrant and third quadrant. Notice, though, that I have a little bit of work to do here. Basically, I don't want anything multiplying directly with x. If there's something multiplying directly, it means I should factor it out. So with this case, I'm going to factor out a -1. So I'm going to factor out a -1 so that in the denominator, so 4 divided by -1 is a -4, and negative x divided by -1 is a positive x. And then I have this -3 at the end there. If I do that, then I can clearly see that I just have a shift there, and then factoring out that negative gets me my reflection. So we're going to reflect over the x-axis, and then we're going to have these two shifts where, let's see, -4, so that'll be to the right 4, and -3 means we'll go down 3. Okay, so if I grab some key points for my basic function, it should look something like this. We're going to reflect over the x-axis. So if I'm at -1, -1, now I'm going to move to -1, +1. And just reflecting each of those over the x-axis. And then same thing over here. If I'm at 1, 1, I'm changing that y value to negative, negative, negative. Alright. Now I'm going to move the asymptotes, but it's going to hold its same shape, meaning I can see I'm graphing in the second and fourth quadrant, so that's going to hold true. I'll have those similar coordinates, it's just I'm moving the asymptotes. And I'm moving them right 4, 1, 2, 3, 4. And I'll just draw a solid line. And then down 3, so 1, 2, 3. So those are our new asymptotes. And then what I'll do is graph these points. So just kind of using their distance away there. And see, I'll have this graph down here. And similarly over here, something going along those asymptotes there. But what kind of holds is this point that's like 1, 1 away from the origin. It's just our origins here now, so we're going 1, 1, 1, 1. Alright, so those can get messy. Again, if it helps, you can erase your work as you work on it, or using different color pens, or using a thicker pen to kind of give you that end function. Just making sure that it's clear where you end